Welcome guys, this is our 3.2, 3.3 video. At the top, I'd like you to write 3.2, 3.3 video, and we are adding, subtracting, multiplying, and dividing with inequalities. And there's a great picture I drew for you because I am quite the artist. Anywho, we're going to jump into today. We're not looking a lot at vocab today. We are looking primarily at how we're going to solve these. So we're going to take some problems with adding, subtracting, multiplying, and dividing. So if you feel like you have got this down, I would like you to try the problem before I do it and then watch me do it, or make sure you got the right answer. If you don't know how to do this, make sure you guys follow and track, okay? So we're just going to do some examples today, no notes or things to copy down. In class we did make our little flip charts, so I don't know where I put them, but anyways. Okay, let's go. Alright, well, welcome, and let's get started with number 1, which is quite a doozy. Okay? What are the solutions of negative 3/4 times w, which is greater than or equal to 3? Check and graph your solution. Alright. Well, first of all, it is right next to it. It is multiplying, but we don't multiply by fractions. Instead, we are going to multiply, we should divide. What am I saying? There is multiplication here. The inverse operation that we learned would be to go ahead and divide it. Now we don't divide by fractions, so what we do is we multiply by the reciprocal, so we flip it. So we're going to multiply this, and let's switch our color. We're going to, let's go blue. We're going to multiply by the reciprocal. And if it's negative, this has to be negative, and the 4's will cross cancel and the 3's will cross cancel, and we'll be left with w, which is exactly what I want. I want it to be alone. But whatever I do to one side, I have to do to the other side to keep myself balanced. So I'm going to come over here and I'm going to multiply by negative 4 over 3 and put this over 1. Now, multiply straight across the top. 4 times 3 is a negative 12. 1 times 3 is 3, and this becomes a negative 4. Now you'd be like, Mr. Smith, you did not write the inequality in there. And that's because we have a very special rule. We wrote it down already, but our special rule is that when we multiply or divide by a negative, which we just did, notice I just divided by this piece right here, which was multiply by this piece right there, which is negative, then what I have to do is I have to flip my sign. So greater than or equal to becomes less than or equal to. And when we graph this, we are going to get 0 right here, negative 4 right here, and I'm going to put a 4 over here. And so we're filling in the circle because it's our equals to. And so we got negative 4 circled in, and this says w is less than negative 4. What I like to do is just double check. Let's pick a point on either side. So we got 4 over here. I could do even a further negative number. So let's try 4. Is 4 less than or equal to negative 4? No, so I shouldn't be graphing that way. Negative 10. Is negative 10 less than negative 4? Yeah, so I should graph towards that number. So sometimes it helps to create an extra number there. Alright, let's get our next problem. Okay, so here we go. Number 2. A student club plans to buy food for a soup kitchen. Make sure you write down the problem. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible number of cases C that the club could buy? So first we have to start with an equation. And when we want to start an equation, we should get one solution. However, it says the word at most, so I underlined that. That's a key word. So at most $50. Can I spend $60 then? No. Can I spend $50? Yes. So we have 50 is acceptable, but I cannot spend anything greater than that, so I have to spend less than or equal to $50. Okay? And I want to see how many cases I can get, and they cost $10.68 a piece. So $10.68 per case. Now, calculator out, ready to go. So let's go ahead and see how many cases could I afford. So if I had one case, it would cost $10.68. 2 cases, I would times 1068 by 2. To solve this, we're going to, instead of multiply, we are going to what? Divide. Okay? So we are dividing with this inequality. Notice I'm not dividing by a negative, I'm just dividing. So I'm not going to flip the sign, so I can keep the sign the same. So we just have to do that in the calculator. So I'm going to do 50 divided by 10.68. So you can see there I got 50 divided by 10.68 equals, look at that gross number, I'm sorry. Look, it says 4.68. So the cases has to be less than 4.68. Now, does that make any sense to have 4.68 cases? Can you buy partial cases? No. Can you round up? No. So you're going to have to go ahead and just round down to the nearest whole number because you can't buy partial cases. So C is going to be less than or equal to 4 cases. That's the most I could possibly buy. Okay? And again, our inequality stays the same. Only multiply, divide by a negative will flip it. Let's try another problem. Okay, let's take a look at this next one. 3. What are the solutions for negative 9y less than or equal to negative 63? So we got negative 9y less than or equal to 63. Again, I see multiplication here, so I'm going to divide by a what? Negative. Because I'm dividing by a negative, these will cancel, I get y, but my sign's instantly flipping. And then this is going to go in 7, and it changes the sign to a negative 7. So when I graph this, oh, that graph is really sideways, I apologize. We have 0 here, negative 7. We'll put another number down here, negative 10. We're going to close it in because I see that equals bar. Y is bigger than negative 7. So let's try 0. Is 0 bigger than negative 7? Yes, so I should probably graph in that direction. Okay? Alright, let's try another problem. So many. Okay, number 4. Solutions of n minus 5 is less than negative 3. Well, I see a negative 5. The inverse would be to add. And we get n is less than. Notice the sign does not flip. Only flips when I multiply or divide by a negative. It doesn't matter if negative 3 is already there. I'm not multiplying or dividing by a negative. Okay, I'm just adding 5. Negative 3 plus 5 is going to give me a positive 2. Go ahead and graph this little guy. 0, 2, put a bigger number, 10. Open circle because I don't see the equals. And now let's try numbers. Is 10 less than 2? Nope. Is 0 less than 2? Yes. So we go that direction. Always go towards it. So pick a number, plug it in, see if it works. Next. Okay, this will be our last one. Number 5. Number 5. Okay, t plus 6 greater than negative 4. Minus 6, that's the inverse operation. Ooh, I'm subtracting, so I'm going to flip the sign, right? Wrong! You're not flipping the sign because you only flip it when you multiply or divide, okay? Sorry, I just get a little animated, but we don't flip the sign. Only when we multiply or divide. I'm not sure if I said this before, but only flip the sign if you multiply or divide, okay? But we see another problem here. 2 negatives make a what? Positive, right? Wrong. That's only when you multiply. Okay. When we do negative 4 and we subtract 6, it just becomes more negative. So the sign does not flip. And this does not become positive. And I'm not really subtracting necessarily. I'm getting more negative. If I were to look at a number line, we would go ahead and see that 0 is here, negative 4 is here, and I'm subtracting 6. So I'm going to go back 1, 2, 3, 4, 5, 6 spaces, all the way to negative 10. And then I'd graph that on my chart. And why do we graph our answers? Because inequalities have more than one answer. And a graph is a great visual to display more than one answer. We have negative 10. Open circle. T is greater than negative 10. So we're going to go ahead and graph towards greater numbers, like 5. And there's our answer. Woo. All right, guys, we're going to get some more practice at this. We're going to become unstoppable. All right. Peace.